Minimac Systems was ideated with a vision to spearhead technological evolution in the field of industrial lubrication reliability.
At Minimac, we are driven by the thought that tomorrow must be better than today. This keeps us ignited for continual improvement and to find a better solution in line with sustainable development and cost-effective products.
We help these companies to achieve their profitability by either increasing the reliability of the machines or reducing their operating cost by reducing downtime.
Minimac implements EJCS very strictly, that is, End Job Customer Satisfaction.
Minimac believes in a prompt delivery within a lead time of 4 to 6 weeks because we understand the customer's requirement. As he ordered us, we have to deliver the goods within a stipulated time period.
As you already know, Minimac has a global presence and is a multi-sectoral company, being available in front of our customers at the right time with the right product is quite challenging for us.
As a company, we are focusing on youth empowerment as our 40% of strength is between 21 to 26 years. Also, we are ensuring gender parity in all our recruitment drives. Every year, we are hiring fresh engineers and management trainees for employment and internships.
Hello everyone, a very good evening. Welcome to our Series 2 finale webinar. I am Jhumpa Mukherjee, Brand and Media Manager at Minimac Systems. Coming to what we are going to discuss today, as we know, improving the plant's lubrication program can be the greatest factor to avoid unplanned downtime. There could be many reasons, including corrosion, overload, misalignment, etc., why machine components fail prematurely. But the most frequent causes are related to lubrication. The topic of today's webinar is how to increase overall plant efficiency by better lubrication management. To discuss this important topic, we have with us Dr. Yogesh Kumar, Head of Technical Services Department at Minimac Systems, and Ms. Bhavti Pataria, Head of Marketing and Branding at Minimac Systems. The flow of the webinar will be presentation followed by AMA session, that is Ask Me Anything session. Before moving ahead, I would like to remind you all to drop your questions and queries in Q&A box, not in the chat box. So let's start. Over to you, sir.
Thank you so much, Jhumpa. Hello, welcome everyone. Very good evening, good morning, good afternoon, whatever the time is there. Please accept my regards. So today's topic is going to be very special because it is not something very much related to a traditional concept, but somewhere it is linked with the common mistakes what we do. So we are going to talk about how to increase overall plant efficiency by better lubrication management. So first part of the topic itself says overall plant efficiency. So we calculate efficiency normally in the terms of performance. Actual definition of efficiency lies with availability, quality, and performance. So even if the equipment is performing as a solo performer, 99% or 100%, doesn't mean that plant efficiency is very, very high. Because if availability of that equipment is low or quality output is not as per the requirement, then the efficiency will go down. So we can see an example for this. Suppose equipment individual efficiency is 95%, quality output is 99%, but downtime due to any factor, maybe due to lack of maintenance or failure of any particular parameter which led to downtime of the equipment is only 6%. So we will calculate overall equipment effectiveness. This will give the actual picture of plant efficiency. So we have to go for product of all these three factors. So if we multiply, it is somewhere near 88.40%. So even if quality is 99, efficiency is 95, the small downtime is affecting the entire effectiveness of that equipment. So now this reducing multiplication factor we will try to cover throughout today's webinar, that how to remove this factor. So just before we move forward, a poll question in front of you. Do you test the oil before replacement or top up? Because oil top up is a normal practice across the industry. And sometimes if oil quality is not up to mark, we go for replacement. So I request you to poll with your genuine practice. Team, can you launch the poll question, please? Yes, so I hope poll question is visible to everyone. So, do you test the oil before replacement or top up? Okay, we have very good poll results. So 80% is the yes, they do oil test before replacement or top up. That shows that audience are very much aware, and we are very happy to know that audience respect the equipment quality so much that they check it in depth. Thank you, everyone. Yeah. Next slide, please.
Yes, so talking about the methods to improve plant efficiency, it's important to analyze the current practices, the processes, and the equipment that are in use at the plant. It is equally important to know the designs and evaluate the same. So timely evaluation, continuous evaluation of the entire processes, designs, the lubrication management, the procurement processes and policies, the maintenance policies and processes should be done in order to achieve plant efficiency. The second important and usually the step that we overlook is invest in training. So timely investment in training your personals, in training professionals at the plant is equally important on how to handle not just the lubricant, which is one of the major raw materials used at your plant, but small equipment on how to do the testing, sampling, and the regular checks, how to notice the triggers that the machine is giving, etc. So an investment in training our human resources on various aspects of safety improvement and efficiency will lead eventually to achieving the plant efficiency. And conducting preventive maintenance. So I'm sure there would be maintenance practices that are followed at your plant. Some have a entire chart and a schedule of preventive, predictive, condition-based maintenance practices. So that's a different topic, and it will require a detailed webinar. We have done it in past. You could go through as well. These are the 3 points. Along with it, talking about more, it's updating your equipment. So moving with the technology in time, moving with the updation that your plant requires, that your manpower requires is equally important. So an investment in updating your equipment in use as per the industry demand would eventually lead to plant efficiency, followed by automating your technology. So here we are not talking about automating something which makes the task easier, but we're talking about automating and using technologies in your equipment and plant, which would make the tasks and people at hand more smarter. So smarter decisions where there are less chances of human error, where negligence is not a concern or it doesn't lead to major loss. The triggers nowadays could get through a phone notification. So there are a lot of IIoT platforms and IoT augmented realities and AI tools that are available, which could be used at your plant level so that these triggers are not ignored and right solution is provided at the time, and so that you can avoid a bigger loss or a riskier situation at your plant. Organizing your plant. So organizing all of these points that we just discussed and having proper processes at your plant for each function, for each department, for everything that is running in your plant is very important, because let's understand that here we are talking about one of the major resources that is used in your plant, and how do we increase overall energy efficiency by better lubrication management. And we all know that somewhere around 2.5% of carbon emission is reduced by increasing just 1% of energy efficiency at your plant. So just imagine a 10% increase in plant efficiency could lead to a reduction of 25% carbon emission. And last but not the least, reducing the material waste. So very important factor again, why the in-service or why the lubrication procurement goes through a process, and there are certain parameters which we would study in furthermore slides to come. This directly impacts cost. So raw material wasted is a reduction in profitability. So lesser raw material would increase and directly impact higher profitability at your plant, which will also lead to plant efficiency. So these are the factors which, if we try to implement each and every one at our plant, this could lead us further and improve our energy efficiency at least by 0.5%, which is one step closer to achieving 1% efficiency and furthermore. Talking about impact of lubrication reliability across all sectors, I'll pass it on to Dr. Yogeshi again. Sir?
Thank you, madam. So, lubricant is a word. It is related to two different sectors. One is the sector where it is getting manufactured or produced, and another is consumer sector. So when we talk about the lubrication reliability, it will impact both the sectors. How? The reduction in consumption of lubricant will directly impact the carbon credits or carbon footprint generation in the refineries, in the oil rigs. And the second part, where the user comes into picture, like steel, power, cement, automobile, transportation, marine, etc. So if lubrication consumption goes down, the profit, or we call it cost of production or cost of generation, will come down. So overall profitability will go up and the carbon emission will also go down. So if we see the overall impact, saving one drop of lubricant is saving for our industry, saving for environment, and at the same time we are saving at the point of generation, which is the refineries or lubricant production industries. Next slide. Now, what to avoid? To avoid failure is topmost motto of every industry. So how to avoid failure has multiple input arrows, like contaminated environment can be avoided. So contamination addition to the lubricant will come down. Then contaminated lubricants should not be kept in service. How to do it? Test your oil before go to fill an equipment or going for oil top up. Then insufficient or over lubrication, both are dangerous. Insufficient lubrication will lead to failure of component due to high friction. Over lubrication will lead to failure of component due to low heat dissipation. Heat will not come out of the friction surface or rolling surface, and gradual increase in the temperature will ultimately result into component failure. Then wrong lubricants. The selection of lubricant is mostly done by the original equipment manufacturers, and we always recommend to follow their guideline. But sometimes a typical application needs revisit the guidelines. Like we purchase a bearing. It is something, suppose 6310 double Z. Double Z is nothing but both sides sealed bearing. So the lubricant is already filled at the manufacturing station itself. Now bearing is at our plant, we are going to use it. Manufacturer is not aware that this bearing is going to be used at Antarctica or South Africa. If it is to be used at somewhere at a very elevated temperature area, maybe your EP2 grease will not work. Or if it is going to be used at Antarctica or tundra, then your EP3 or EP2 or EP1 will even not work. So how to select right lubricant is the duty of user always, apart from the duty of OEMs. So we call it tropicalization of lubrication system. This is a very vast subject. Maybe in upcoming webinars, we will take it as a special topic. How to select the right lubricant. Too much of lubrication, just now we talked. Component wear. Component wear is directly proportional to your method of lubrication or the vibration of equipment. If vibration is at the higher level, oil film will break, then in metal to metal contact, and final component wear. Oil film breaks only not due to high vibration, but maybe sometimes due to high temperature or availability of few bigger particles in the oil. Bigger particle doesn't mean very big. I'm talking about just 15 to 30 micron is sufficient to tear off the oil film, because oil film thickness is 10 micron to 25 micron on an average. Ineffective seals, just like I gave an example of sealed double Z bearings, like that if bearing seal or oil seals are not proper, then contamination will increase. Contaminants will start entering into the oil or any lubricant, whether it is oil or grease. Then damaged seal. Yeah. We normally think that seal is just to prevent the oil or grease seepage from the system, but it is its half duty. Remaining half is to prevent any dust or moisture ingress in the lubricated area. So damaged seal is never acceptable. Next slide, please. Now coming to best practices in lubrication reliability. This is something like that we all know. We should not speak lie, we should not harm anyone, but we do, sometimes knowingly, sometimes unknowingly. So best practices are there always in our mind, but we always keep it as a special slide in our webinars, just to remind it, like your saint or priest sometimes do in their discourses. So if you see the arrows, according to different industry, the criticality and oil replacement factor varies. In few industry, oil replacement factor is very, very high, because their contamination level goes high rapidly. For an example, mining industry, it is full of dust, and those dust contain number of minerals. So the small value of contaminant itself is sufficient to degrade the oil at a very great extent. Then marine industry, when ship has to go for a sail for 6 months continue, so that time we don't have a choice to take any chance that we will not replace the oil as per the OEM guidelines, because still it is able to serve the purpose for a few more hours or days or weeks. But in between the high sea, the ship engine fails, is very, I can say, risky, dangerous. So at that time, replacement factor will dominate. Few industry like plastic, automobile parts manufacturing, criticality is high, but replacement factor should not be high, because those industries are on land, they are not going to sink. So there we can think for the reclamation of the oil or refining the oil, checking the oil quality periodically and take the appropriate action. So before taking any decision regarding the lubricant, we have to see the criticality of the equipment and replacement factor, whether it is going to dominate or we can dominate it. Next slide, please. Yeah. So just now we were talking about the contaminants, like discussed in the mining industry, where we have to work with the minerals. The rate of degradation is very, very high compared to the industry, which is away from the much dusty environment. So what type of contaminants we need to check on regular basis? These checkpoints are not valid for every equipment. These are the total checkpoints. Maybe 4, 5, 6 or 7 is specific to a particular equipment and remaining may be valid for the another equipment. Like moisture, it is common for all. Chemicals, air, water, glycol, these are common for every industry. Now coming to heat, yes, it is also almost common, but soot is common for automobile industry mostly, or the high temperature application like drilling and other things. Then foam is also very important factor for every industry, but in some cases like quenching oil or other things, then this foam doesn't play a vital role. Fuel. Is fuel a contaminant? Yes. When we talk about the lubricant, fuel is contaminant. One liter of fuel or hydrocarbon is sufficient to sufficient to disturb the chemical property of lakhs of liter of the lubricant. It can spoil the entire oil, entire lubricant. Then particles common for every industry. Other lubricants. When we are talking about the contaminants, why we are talking about the other lubricants? Every lubricant is not the same. The lubricant used in as the engine lubrication, which we put in a crankshaft chamber, and the lubricant used for turbine, both got different properties. Lubrication and cooling is the ultimate target, but based on the operating hours, operating condition, they got different additives, and sometimes additives support each other and sometimes they react with each other. So in general terms of lubrication, we call it cross contamination, mixing of two different lubricants. When it happens, when lubrication practices are not maintained ethically, or sometimes it is ignored due to lack of awareness or laziness. So the same oil pump is being used for different grade of oil. Oil pump, I mean to say barrel pumps or oil transfer pumps. Then we are increasing the probability of cross contamination. Next slide, please. So all these we will go through in detail in our upcoming slides today itself. Bhavti, we can jump this slide because these are nothing but already discussed. Yeah. Okay, a poll question again. What's the frequency of varnish testing in your company? Till now, we have not spoken a single word about the varnish. All type of tests, contaminants we were talking. So why we missed this very important topic, varnish? Okay, we will see why it was not taken till now and why it has to be taken in upcoming slide. So what is the frequency of warning testing in your company? Maybe quarterly, half yearly, yearly, or sometime we don't test it. Sometimes we don't test it because OEM has not recommended for it, or awareness level was not up to mark, or our application is like that. Varnish has no role. This may not be true. This may be an assumption that varnish testing is not required here. So please vote. Yeah. Okay, this time we have mix of results. So maximum 33% quarterly. Then at the second level, none of the above. Then we have half yearly and yearly almost 17 and 23% respectively. Okay, so we will see varnish testing shall be done or not, then at what frequency it should be done. Varnish is a very interesting topic, and surprisingly across the industry what we saw practically, still people are trying to validate the Newton's law. Once it is validated, accepted by the universe, still if we try to check it whether Newton's law is right or wrong, then we are wasting our time. We have to think ahead of this. The same thing is happening with the varnish. Okay, so what to check before oil procurement? Now we will go one by one from procurement to application, then discard of the oil. So when we are going for oil procurement, we have to check grade of oil, not only oil procurement, oil purification system as well, valid for both. How? Grade of oil, it should be as per the recommendation of OEM, and the machine selection for the filtration we have to do like in a such way that this high viscosity oil or low viscosity oil can be filtered through that machine. Type of contaminant. Yeah. So when we select a filtration machine, we have to see the type of impurity present in the oil, because we will keep on doing the vacuum dehydration to remove the moisture, but the contaminant is solid one. So selection of right filtration media and right machine will depend on the type of contaminant. Then ingress rate of contaminant, this is directly with the rate of filtration. If ingress is very, very high, then we have to keep our filtration rate very high. Tropical condition, we have spoken a lot on this. So where this machine has to be used and where this oil has to be used, the tropical condition we need to see. Tropical condition doesn't mean the continent or country. This may be the exact location where the system has served the purpose. Like across the industry, a particular zone may be very hot. If machine has to work there, then seal should be of white-on material, not for the normal butyl rubber. So like that, tropicalization is important. Criticality of the system. How many interlocks should be there in the machine that even at the worst case, this machine should not disturb. I mean, filtration machine should not disturb the functionality of main equipment. Main equipment means the equipment installed in the industry for some purpose. Then required processing capacity. Yeah. If we have 400 liter of oil and we are fixing their 100 LPM machine for filtration, doesn't make any sense. Every 4 minutes it will complete one cycle, maybe in 10, 15, 20 minutes your oil will get purified, and then machine will filtration machine will remain idle for next 23 hours 45 minutes. So sizing is important based on the quantity of oil we are going to handle. value for money. Yes, we are talking all these things. Ultimate goal will be saving. Saving in terms of resources, environment, and definitely money. So selection of machine or lubricant should be in such a way that optimum utilization can be done. It should be not undersized, not oversized. Next slide, please. So this is a chart made based on the selection of machine and contaminants. Like for the solid contaminant, out of 5 machines are capable, but those 5 should be used just only for solid contaminant or not. You have to see the capability of machine. Like MLC LVDH, it is capable to remove multiple things. If we talk about the FS series, it is just for the solid contaminant. If we talk about the tricks, it has most wide range across the machines. But whether this is required for our application or not, that need to be judged carefully always. For the varnish, you can see all the machines are in yellow zone. No red, no green. Because varnish is something different. We need to understand. Next slide, please. If time permits, then before completion of today's webinar, we will get into depth of this varnish. Otherwise, we will try to cover it in brief. So, after procurement, reception. Now see how contaminants are getting added. Blending of lubricant, because base oil will get blended with the additives. So it is done in a chamber, then getting transferred to multiple pipelines. So there is a great chance of especially solid and moisture contaminants addition. Because suppose one tank is empty, then empty means it is empty in terms of lubricant, but air is inside. When we fill the lubricant, air will come out, but the impurities will remain in the tank. So they will get mixed with the oil. Storage tanks of lubricant. Yeah. So tanks, barrels, or we call sometimes them IBCs, intermediate bulk containers. Those are manufactured by someone else, not by the oil manufacturing companies. And then the process of manufacturing itself leaves back lots of contaminants. And when we fill the oil in the tanks, barrels, container, then contaminants get added with the oil. Even they take very much care before filling the oil into barrel. They first purge it with nitrogen, dry and clean nitrogen. So all the particle and air will come out. Then they fill the barrel with lubricant nozzle. But till the time nitrogen flushing is going on, the oil nozzle was out of the barrel in an open environment. So it will again add a small quantity of contaminants. So sometimes we saw that practically it is our experience, NAS class 4 was the oil quality before filling into the barrel, and at the reception end, at the user end, it was NAS 8. So during the transportation also contaminants get added because the oil barrel or oil container always breathes due to variation in day and night temperature, due to fluctuation in oil level during transportation, other factors. Next slide, please. Yeah. So when oil is received at our end, now what to do? First go check with sticker or label pasted over the barrel or container. Uh, we are not blaming someone especially, but sometimes it happens tampering of the content during transportation or some wrong formulation of oil has arrived at site. So we need to check the label very carefully. Oil has limited shelf life. So how much life already gone, whether this batch is new one or old one, like that. Then lube test certificate, that is always provided by the supplier if we ask. So always ask the supplier to send it along with lubricant. Then when a batch arrives at site, we can go for random testing of few barrels. Suppose 100 barrel oil received. We can take sample of 5-6 barrel randomly. We can check for the moisture, viscosity and particle test, and it will take hardly 10 minutes to perform all three tests. If we have portable devices with us, and definitely we should have them handy always. Next slide, please. Yeah, just now we were talking. Barrel breathes, yes, of course. You might have noticed before also, you can see ribs over the barrel, two lines. They act as stiffener up to certain extent, but they also act as expansion joint. Whenever there is variation in the temperature, the volume of oil will vary since this container is sealed. So to take care of the expansion, or contraction of the barrel, these ribs are there. Still, oil barrel will breathe because this is not airtight seal, never. So whenever tank breathes, it inhales contaminated or moisture laden air, and whenever it exhales pure air. Why pure air? Because contaminants are already absorbed by the oil. Oil has affinity towards contaminants. So why this affinity is there? You can check with the Gram's law of diffusion or osmosis. How due to concentration difference, contaminants move from either side, from one side to another side. Next slide, please. Yeah. So now this is about the storage of lubricants. We should always avoid vertical storage, like we saw in our last slide. We should prefer horizontal storage. In the picture, if you see, this method is also incorrect. Horizontal storage, yes, it is being followed here. But if you see the points from where the oil is filled or to be taken out, they are at 12 o'clock and 6 o'clock position. They should be always at 9 o'clock and 3 o'clock position. Why? This tank has some header space. So right now, header space is on top and the breathing point is also on top. It will improve the chance of breathing. But if we keep the barrel in 3 o'clock or 9 o'clock position, then there is very, very minimal chances that tank will breathe. But these ribs will take care of the expansion and contraction. Because these seals are sufficient to prevent leakage of oil. So We have various methods to store the oil. If we don't have facility to keep it horizontal, then how to store it vertically. Next slide, please. If we have picture, we can show. No, we don't have that picture. Okay. So sometimes we have plastic covers available to put on the top of the barrel in storage area. So if we have to store it vertically, we can wrap it with polythene or plastic sheet, or we can keep it ready-made plastic cover on the top. Next slide. These are few pictures taken from site, so really looks pathetic. You can see jute thread should not be used as a maintenance cloths. No, because it has lints and threads. Visually we are not able to see it, but whenever we clean a surface or bearing housing or gearbox with the cloth, lints always stick with the wall, and when we fill the lubricant, they get mixed with the lubricant and degrade it. Then you can see for oil transfer how contaminated pipe are thrown here and there. For oil top up, dirty cane is being used as accessory. There are standard accessories available for all the work. If picture is available, we can see on the next slide. Yeah, we have. These canes are standard canes, and they are designed to serve the purpose of dust-free or contamination-free lubrication. These are readily available in the market. So based on the application, you can choose them. They are different in color intentionally, because one type of oil shall be used with one color, another type with another color. So even a person who is not well educated cannot make mistake while going for oil top up. By seeing the container cap color itself, he can judge that which oil he has to put in which machine. What happens? Suppose a container has a cap in yellow color. The same yellow color, a small sticker we can put on all the lubrication points on the machine where this oil has to go. So by matching the color itself, one person can see that whether he is putting the genuine oil or recommended oil, or is there any chance for oil contamination. Then again, if we store oil in the barrel for top-up purpose, suppose daily 2 liter or 5 liter oil we have to take out from barrel, then we can make this arrangement. One tap at the smaller end or a smaller opening, and a breather on the bigger opening, so that as oil will come out, it will try to take the air from atmosphere. So through the breather and fine mesh at the bottom of breather, contamination-free air will enter into the barrel. So we will get the fresh oil, clean oil always. And you can notice that there is a small sticker there over, or card. We call it oil tag. It has all the details, which date this barrel was placed here, then what is the grade of oil, may be marked also to which machine it has to go. These all are part of lubrication practices, and definitely training of our technicians and engineers will help us to establish this system in our industry or in our factory. Next slide, please. These pictures are not taken from any website or somewhere. These picture we took our own. In the first picture, you can see oil condition. In the second picture, how the sampling was done. What we expect from this sample? Any result? Chanceless. In the third picture, you can see the lab condition. Can we expect a good result from this lab? Even if our oil quality is very, very good, during the testing itself, it will get contaminated sufficiently. So, from sampling to the testing, there is always a chance of contamination addition. If this part is done seriously, sincerely, then the next part will come, which needs to be focused again. Next slide, please. Yeah. This is something about oil testing or oil sampling, because oil sampling also has got an standard 11171. So what we should do during the testing or what we should not do, then what should be bottle cleanliness level, whether it is clean, super clean, ultra clean, or what is the requirement of our site. Do we need ultra clean bottle or just a super clean is sufficient? Depends on the criticality of the equipment and the test. So if we talk about the effective oil analysis program, we need to focus on the 4 factors: maximize the data density, minimize the data disturbance. Minimize the data disturbance is nothing but sampling error or testing errors. Maximize consistency. The standard test method has to be followed every time so that result can be analyzed or a graph can be made easily, because result will be on the same platform. At maximum relevance for a gear oil, no need to go for 10 tests, but yes, definitely you can go for wear debris analysis. For a governing oil or EH oil, what is requirement of WDA? Wear debris analysis is not much relevant there. We can do it annually even, but TAN, total acid number, is very critical. So based on the application, relevance of test and relevance of data comes out. Next slide, please. These are some common factors or frequency for the general machine. It is not for any specific machine, or this slide is nothing to be followed like a holy book. These are general in sense that for application like steam turbines or gas turbine or boiler feed pumps, like that, this can be followed. But if your application is something very critical or different, then certainly the frequency will vary. The test standard will remain same. These are the test standard. Based on these, you will get the central picture, that is nothing but test report. So interpretation of test report is something we have to take a special care of. Just by seeing the red, yellow, green doesn't make real sense. We have to see why red or why yellow. The limits, what is set here as per the laboratory, may not be the same set by the OEM. Laboratory may say you that TN value up to 0.5 milligram of KOH per ml is acceptable value. But if you see critical machines, you will see that maximum TN value they allow is 0.1 milligram of KOH per ml. So oil manufacturer has their own standard. It is for their oil, not for your machine. Oil can sustain on 10.5 happily, but may not be in case of your machine. Okay, let's move further because I think time is running short. One poll question for you once again, and please give your genuine opinion. So, do you think about the carbon footprint left behind? Think what is carbon footprint when we are doing oil top up of 1 liter or 10 liter something, so that 1 liter of oil will leave how much carbon footprint? We may have idea, we may not have. Every oil has its own characteristic. Some oil may leave huge quantity of carbon behind, some may leave very less. Let us see. Where is poll result? Okay, 76% audience, yes. Thank God. And thank you audience for your awareness level. And I think after this webinar, this 24% will come down because we need to think over it. We don't have to think about our life only, but upcoming generations may have to suffer if we don't take care of it right now, because we live for us, we live for our children, and they have to live for their children. So everyone has to think for next generation. Next slide, please. Yeah, so now coming to reconditioning. Reconditioning is the area full of myths. What we see. Reconditioning is not like that. We are going to give life to a dead body. No, it's not that. Reconditioning is also part of preventive maintenance only. Recover it before it is unrecoverable. So here we have some definitions and the actual practice. We try to recondition the oil in service always. And in terms of monetary benefit, they think that oil conditioning is an expenditure to the company. Yes, no doubt, oil reconditioning is an expenditure. But instead of expenditure, you can call it an investment. You spend 1 rupee, you can save 100 rupees. Or you invest $1, you can save hundreds of dollars because of it. So when we select the method of oil reconditioning or oil reclamation, we should be very much conscious about the factors what we have discussed in the previous slides. Check before you procure. Then whenever you find the low cost solutions that are welcome always, but we request you to go through the checkpoints once again and see that whether that low cost equipment or methodology is serving your ultimate purpose or not? If serving for the time being, then how long? And what will be the impact on the lubricant? Because we have seen in past few machines, they perform the removal of solid impurities very effectively, and in due course of operation next 6 months, customer replaced the entire quantity of oil due to high foaming, because the low quality material used in the machine got mixed with the oil in certain periods of operation and resulted into degradation of many additives, or contributed in the increase of many metals like zinc, then something like calcium. Their ratio went high and caused the soapy ions in the oil. Soapy ions will ultimately result into high foaming, and those foaming cannot be controlled using anti-foaming additives. Very specifically, I am saying it. Soapy ions are very stable ions and they make very stable foam. Next slide, please. I would request to Bhavati madam to take from here onwards.
Thank you, sir. So why reconditioning is important, what could be achieved, and why we should do it. So we all know the benefits. We have discussed some or the other way in this PPT, though it is important to understand that extending the oil life, which is the in-service oil life, could be achieved by oil reconditioning. Increased in machine reliability, that is, your machine is available for a more time duration and in an effective way than you think if it is not maintained well. Reduced environmental contamination, because the contaminated oil, the waste oil, usually we discard it or we sell it to be used further to the downgrade application, that it can be used as a downgrade application as a raw material, but it again adds to the environmental contamination. Cost saving on oil replacement. So it is not necessary to replace your oil as and when it is contaminated. The properties could be reclaimed back so that there is a drastic reduction in the procurement cost of the new oil. We have seen time and again that approximately 20 to 25% of drop in the procurement cost has been seen at multiple plants in various sectors in India and internationally, which eventually leads to higher profitability. So I'm sure all of you are very much interested to understand the dynamics of saving the cost on new oil procurement and leading higher profitability. Time and effort saved for oil change out. Again, a lot of time and efforts of manpower and the machine downtime is also saved out here while reconditioning is followed. Decreased waste disposal cost, very important. Environmental norms again have certain criteria. There's a particular fashion and a way how waste is to be disposed after certain treatment. So if there is lesser waste, so obviously there would be lesser disposal cost as well, leading overall operational cost reduction. Low carbon emission, this is very important factor. In order to achieve and in order to move toward the pathway of net zero carbon emission, the entire world is struggling, is acing up their game in how to reduce this. So I'm sure if you, me, and all of us take our own individual responsibility at the plant and increase efficiency, opt for reclamation, some percentage of carbon emission could be reduced. And sustainable development. All of these factors eventually lead to sustainable development, which just Dr. Yogesh covered a while back. How do we come into the picture? What do we do? So Minimac supports an end-to-end lubrication management at your plant. Right from the point when a new fresh lubricant is arrived at your plant from a uh, a lubricant manufacturing company. As we all know, in transit, once the barrel opens up, it directly is contaminated from NAF 7 to NAF 10, 12 at any limit. We have seen many episodes recently where the OEMs and the power plants and steel plants require oil first fill at a very pure level, at superfine pure levels like NAS 4 and 5 for better equipment reliability, leading to asset reliability. So right from the new lube that comes to your plant, from storage and handling, new lube room management, we have an end-to-end solution. We have designed a program called Reliability Improvement through Lubrication Assessment, which is RELA, where there are different parameters of lube management that is covered, the best practices, handling, storage, etc., sampling, oil analysis. And we also have an MOMS team, which is Minimac Operations Maintenance Team and Services Provider, where we do manpower services and technical consultancy apart from the machines and the expertise manpower that we have, which we provide. So I understand the entire industry, there has been a shift that we see that service is something which is very important, and not many would want to invest heavily in capex budget, but there's always an option of reduction of cost through better lubrication management if handled well. Reconditioning of oil is our strength. We are technology build company. Building technologies is our strength. So all the problems that we discussed, may it be varnish, may it be foaming, soapy ions, moisture, solid contamination, tan reduction, all of these problems could be solved through the conditioning of your oil at the plant. How do we contribute to this? So we are trying to contribute and build a circular economy and build the ecosystem where we are accelerating the adoption of cost-efficient technologies and practices. So kindly underline these words, cost-efficient, which are affordable solutions. Again, customization is our USP. As per your problem, as per your equipment and need, we customize the solution and provide, which improves the reliability and performance of lubrication and hydraulic oil systems. Our vision ultimate is to achieve zero mechanical breakdown. With all of it together, I'm sure we will achieve it one day. Life cycle improvement of the oil, adapt and promote socio-environmental responsibility. So this is how we contribute towards circular economy, towards building an ecosystem where everyone realizes that by doing their bit, by increasing efficiency, there can be an impact which is proven to carbon emission, a reduction in carbon emission. Further, if you want to increase your productivity, uptime of your machines, the running hours of the machines, the availability and the reliability of the machines, you know, these are the parameters that at a plant level which matters the most. You know, the downtime is less, the uptime is more. So what are the checkpoints for it? So we have a list of checkpoints. Some of it are mentioned here, like the lubricant contamination levels, types, condition of the lubricant, the different grades of lubricant, providing the reclamation option of oil filtration, dehydration, or reconditioning, or nitrogen capping, reliability-centered lubrication. So considering that the lubrication is 100% fully optimized in your plant till its full life is what we ensure. And for that, we design the solutions as per your requirement. Quickly running through a case study here, there's a power plant in North India using Indo-Japanese technology turbine EHS system. Let me tell you, this plant showed their awareness towards lubrication reliability, and they opted for the reconditioning of oil product and services from us. And with their proactiveness, they could manage a cost of oil replacement of 44 lakhs, which is around $50,000 here we are talking about. and save the downtime cost of around 1 CR. So just 15 hours of equipment downtime costed them a loss of 1 CR, which is approximately out here $250,000. So we can see how through oil reconditioning and reclamation, this cost was saved and they opted for better services and lesser investment opting for oil reclamation. We could see on the graph how the moisture in the tan has been dropping down in just 2 to 3 months of time. There was one more power plant in Western India using Chinese technology turbine EHE system. I'm sorry, but we cannot disclose the names of these power plants. And that's why we have just mentioned a little description about them. So again, because of their proactiveness, they could save a major cost for oil replacement, costed them somewhere around 21 lakhs. And the downtime was 2.8 crores, which is $700,000, if I'm not wrong. So 48 hours of an equipment downtime would have costed them 2.8 CR INR and 700,000 USD if they wouldn't have opted for an oil reclamation option through us. So there are many such case studies and case stories. I'm sure you could read out to them later on much. We keep on sharing it on our digital platforms. But these losses are huge. In order to avoid that, if we opt for oil reconditioning, that's much better, with just an investment of 3 lakhs rupees. So the calculation is right in front of you. With an investment of 3 lakhs rupees, which is right now, a bigger problem could be avoided, which would have costed them crores of rupees otherwise. So that's it from our side. Jhumpa, over to you.
Yeah. That was a great presentation by our experts. If you want any details of our services and offerings, please contact us at the mail ID mentioned here. And you can also visit our website for more details on our offerings. Before moving to the AMA session, do you know next year will be full of surprises. You'll get a chance to win Minimac goodies. There will be knowledge sharing sessions, quizzes, and lots more. Stay tuned for more information. Please follow us on all our social media channels. And you can also join our WhatsApp community for daily posts and updates. If you have not joined it yet, you can join it using the link posted on the chat box. Moving on to the AMS session, requesting the experts to please switch on their cameras and unmute themselves. Okay. Before
we move forward, just I was going through Q&A box. Very interesting questions. Really, I appreciate the curiosity and knowledge of the audience as well, because now they are asking questions at a very, very in-depth level. That's great.
Yeah, so because we have only 10 minutes in hand, so if you want to answer some important question, you can please go ahead, sir.
Okay.
Yeah.
Thanks for the opportunity. So one question is from Mr. Alex. He has asked today many questions, and he is trying to connect the lubrication program with Six Sigma or DMAC principle. So definitely Six Sigma or DMAC, both are there just to reach a goal where failure rate is very, very less. Out of 1 lakh, there should be maximum 2.5 or 3 failures like that. So our goal is also in line with DMAC only, and you can incorporate the lubrication program with your any of Six Sigma projects. So you take Six Sigma project for a particular equipment or a particular division of the industry. So if you want to achieve a goal or you want to sort out a typical issue, you take lubricant as a supporting hand, and it will help you to reach your goal very quickly. So definitely we are in line. Then
Okay, so I can see one question, which is from Mr. Mohammed. How can we make a timeline to exchange the oil?
okay. See, the exchange of oil is timeline dependent for some special application where oil is getting consumed or burned. Like in case of your engine oil, it has undergo tremendous pressure and temperature. So the degradation of additive will be very high and mixing of soot with the oil. So once oil is oxidized, this cannot be reclaimed back. There we have to follow timeline. But for a normal application where there is no extreme pressure or temperature, the oil exchange is always condition based. If additives are depleted to the extent where they cannot be recovered, because top up of additives are always there, few additives cannot be blended in due course of operation. In that case, we can take a call for oil replacement, and that too replaced oil can be used in some another application where role of that particular additives is not important.
Okay. The next question is from the LinkedIn Live. What is the role of RBC in terms of criticality, and what things taken care during the selection of RBC?
RBC, I'm not clear what they mean with RBC. Red blood corpuscles in our body, but it is not linked with the oil. So I'm not sure about what they wanted to ask, but definitely they can write it in Q&A box now, so that if not now, then we will share the answer in terms of publication.
Yeah. Okay, so the next question is from Panag Das. How to remove emulsified water content from lubricating oil, especially hydraulic oil?
Yeah. Emulsified oil can be reclaimed very easily. Dissolve one is a bit difficult. Free is always the simplest way. So you can use coalescer system if your oil viscosity is less than 68 grade or 68 centiostokes. If your oil viscosity is more than 68, then you can choose method of low vacuum dehydration. This is helpful to separate all the three forms of moisture present in oil, whether it is hydraulic oil or lube oil or gear oil, any oil.
Okay. The next question is from LinkedIn Live again. Wrong lubricants are bad, but the most important is how can we evaluate how harmful it is, and with numbers. It may be 10% or maybe 90%. And how can we test the lubricants to find out its components?
Yeah. So we have already discussed it, that there are few tests which we need to perform at certain intervals, maybe weekly, monthly, fortnightly, or quarterly, or even annually. So by testing the oil, we can see the condition of oil, and with the help of elemental analysis or FATIR, or there are a few more tests whether we can test the component concentration or additive concentration in the oil. And then we can say that how much oil life is there. A specific test is also there, ruler test, residual useful life of the oil can be tested using that. So it is not a very big science, or it doesn't require much of competency to do all these tests.
Okay. The next question is from Mr. Joseph. Is there any difference between reconditioning and reclamation?
Bhakti madam, would you like to answer this question?
Sure, sir. So there is no difference between reconditioning and reclamation. Reclamation is where we reclaim the oil properties up to an extent, and where it could be used and it is applicable in the machine that we are using, the equipment that we are using. That is what reclamation is. Reconditioning would be more of where the oil properties could or could not be reclaimed back. Am I correct, sir?
Yeah, right. So reconditioned oil may not be suitable for that particular machine from which it came out, but may be suitable for other application. But reclaimed oil means it is suitable for the application from which it has been taken out.
Right.
Okay. The next question is from Mr. Manoj. How to maintain grease consistency at motor bearings in dusty environment?
Very simple. Stop the ingress of contaminants. And how to stop the ingress of contaminant is a big chapter. Like your grease nipples. Always on the top of bearing, you will find one stainless steel or brass grease nipples. Those are for periodic greasing of the bearing. The grease gun is the source of contamination, because once you do the greasing, the gun is kept or lying somewhere in the industry or some shelf or rack. So all the particles available in the air will get stick at the tip of that grease gun, because it is sticky in nature. So when you go for re-greasing, those contaminants will enter, and you are doing greasing for the improvement of your bearing performance, but unknowingly we are degrading its performance. So take care of your lubrication system, then take care of your seals. Seals are healthy, then there will be very minimal chances of ingress of any contaminant to your bearing or grease.
Okay, great. The next question is from Mr. Vinay Pawar. Is it recommended to use reclaimed reconditioned oil in compressors, which was used in lube oil flushing during commissioning?
This is always a subject of debate, but we are very much sure about it. In the oil flushing, we take the same oil which has to be kept into service in future. In case of compressors, during flushing, apart from the solid contaminant, we don't get anything mixed with the oil. So it is advisable go for oil purification properly, then test the oil properties. If they are as good as new oil, please go for refill it in your compressors.
Okay. The last question of the evening is from Mr. Rowan. Do you have methodology to identify the overheating of oil during oil analysis?
See, oil analysis for all the tests, excluding few ones, we don't do oil heating. there is one test for moisture that is called crackle test, in which we heat the oil. So, but in this test, only 2 ml or 3 ml of oil is used in a hot spoon that can be discarded. No need to reuse it. Other test methods doesn't use any heat source. Like for the mechanical impurity, you have particle counters. For the moisture, you have Carl Fisher. For the ruler, mass spectrometer, whatever test is there, heat is not involved. If you are talking about any particular test, you can write it down in Q&A or in our WhatsApp group. We will take it up.
Okay, great. So here we are wrapping series 2 with great success. Thanks to the experts and the viewers. Without your support, it wouldn't have been possible. Thank you for being a part of this amazing knowledge sharing journey. We really appreciate the kind of support we have got from you all. Please fill the survey form and let us know your views and feedback. Till then, I'm signing off and we are signing off. Wishing you all amazing holidays and a prosperous new year. Bye-bye.
Thank you, Minimac webinar team. And thank you, Yogeshri, for this opportunity. I'm sure audience would have missed Anshuman on the show today, but thank you for this platform.
Thank you for your time. And on a very short notice, you came here. And together we wish our audience a contamination-free, carbon-free new year. Stay healthy, stay safe.
Thank you.
Thank you. Bye.
Bye-bye.